All about inverse of relations and functions. We're going to learn how to find the inverse from a graph, and we're going to learn how to find an inverse from an equation. So start with, what is an inverse? So a relation is a set of ordered pairs. So if you can get an XY combination out of an equation, then it's called a relation. A function is a relation in which each x value has at most one y value paired with it. So you can't have the same x with a different y. So if I had something like xy, and I had 2 with 1, and then I had 2 with -1, this might be a relation, but it is not a function. You can't have the same x with a different y. We're going to start by graphing an inverse relation. So to graph it, there's really two ways you can do it. You can either draw your y equals x line, which is a diagonal line through quadrant 1 and quadrant 4. So the y equals x would start at 0, 0, and have a slope of 1. So it would go up 1 over 1, up 1 over 1, and it would look like that. I can either take the graph and fold it along that line to get the overlap, or what I think is even easier is just take your x and y values and switch them. So the x's become the y's and the y's become the x's. So on most of these, you'll already have a t-chart and you just have to flip them, or you have the capability of figuring out your t-chart points and then you just have to flip them so that the y's become the x's become the y's. That's it. You're just switching it. So, first example, it says to graph the relation and connect the points. So I'm graphing the original one and connecting the points, and then graph the inverse. So start with your original. Just plot your points. You've got 4 x, y coordinates there. Plot those and connect them to make the first one. So it doesn't have to be a straight line, which is this case kind of zigzags a little bit. But you don't have the same x with a different y, so this is a relation that is actually a function. So then the next thing I would do is find the inverse points. So I'm going to take those 4 points and switch them. So the y's become the x's, and the x's become the y's. So my x values are now 2, 5, 6, and 9, and the y values are now 0, 1, 5, and 8. And then I'm going to graph those. So 2, 0, 5, 1, 6, 5, and 9, 8. So you should see some symmetry here, right? And the symmetry would be across the y equals x line. So we talked about that as a way to actually plot this graph if I wanted to do it, is I could draw a line that goes right through 0, 0 and up through a slope of 1, so up 1 over 1, up 1 over 1. That's my y equals x line. If I folded this graph along that line, they should overlap. Sometimes it's easier to see than others, and that's why I think it's easier to do the points, especially if you've got them. So then it says identify the domain and range of each relation. So what's the domain for my initial function? What are the values of domain that I'm looking for? Domain is x or y? X. And x runs left or right or up or down? Left or right. So for my initial function, my domain are the values in between this x and this x, which are what? What's the first x that's on that original graph? 0. And what's the biggest x? 8. So x falls in between those 2 points, all the x values. How about the range of my initial function? So now range, we're doing the y values, right? What's the lowest y of my initial function? 2. What's the biggest y? 9. And it's all the y's in between those. Now do your inverse. So what's the furthest to the left x on my inverse?
X.
On the x, 2, right? The smallest x is 2. The biggest x is 9. And the range is the y's. So the lowest point on my y-axis for the new one is what? 0. And the biggest? 8. So again, domain left to right, range bottom to top. Really good question. The question is, can you just switch the domain and range? And yeah, that's kind of your way of checking it. Because we have switched the x and y values from the initial to the inverse, the same thing should happen. Okay. All right, so I just plotted the initial one, right? So I did 1, 0, 3, 1, 4, 2, and 6, 5. And then I want to find the inverse point. So how do I do those? Just switch them, right? Switch the x's and the y's. So the x's should become the y's should become the x's. So this would be 0, 1, 2, 5, and this is 1, 3, 4, 6. And then when I plot those points, 0, 1, 1, 3, 2, 4, 5, 6. Oh, I totally skipped a spot there. Hang on. 2, 4, 5, 6. Did I plot the other one right? Yeah, that 4 is off, but it's right. Okay. And then I connect those points. And again, it should be, if I plotted my little y equals x, if I folded it along there, it should mirror it. All right, so now domain. What's the domain of my initial function? Who thinks they know it? It starts at 1, and it goes to 6. Good. So x is greater than or equal to 1, but less than or equal to 6. How about range? 0 to 5. Good. So y is greater than or equal to 0, but less than or equal to 5. Raise your hand if you got that right so far. Good. Okay, so now inverse. So domain on the inverse would be?
X is less than or equal. The 0 is less than or equal to x.
Good.
Which is less than or equal to 5.
Good. And then the range?
1 is less than or equal to y, and y is less than or equal to 6.
Perfect. Questions? Not complicated stuff, right? So easy so far? So tomorrow, right, because we're at 50, yeah, I'm not going to rush through the rest of it. Tomorrow, we'll finish the section in which we actually take an equation, and we, right, because we take an equation. So if it said like y equals x plus 3, how do I get the inverse of that? So in the assignment, so I'll publish it again, it's just odds, you're checking your work. You can do all the ones that dealing with graphing, and then you can save the other ones for tomorrow, okay? Yep.